Another interesting video with grade 8 student. See the progress. The grade 8 student is learning calculus. We are going to discuss product and quotient rule in this particular video. We'll also take up questions related to tangents and normal. At the end of the class, I will also introduce to him the next chapter, which deals with increasing and decreasing interval. We are going to take polynomials as our base functions to apply the power rule, the product rule, the quotient rule, and take up examples related to tangents and normals. That is how we connect, and that is how our engaging mind strategy work. Join us to learn more. Join Anil Kumar classes, gain confidence, and get ready for future. We develop mathematical and social skills for excellent performance of our students. The gift of education. I can be part of your success story, build strong foundation, ensure bright future. Join Anil Kumar classes, send an email on the address given here. Let us enjoy the journey of learning with Aryan. Hi Aryan, how are you doing?
Hi, sir. I'm doing good. How are you?
Very good, very good. So today, what do you want to learn?
Yeah, today I would like to learn more about calculus and like about all the different rules that
Okay.
are in calculus.
Okay, so a couple of rules there for derivatives, you mean, right?
Yeah,
So
yeah.
we'll look into these rules and see how it works out. Let me share with you first a few pages which I have for you, and then we'll look into your pages which you have shared. Is it okay?
Yeah.
Okay. So this is about the derivatives of functions. As you know, we found the derivative, which is written as f prime x
Yeah.
as limit x approaches 0 for f of x plus h minus f of x over h, right?
Yeah.
So that is the derivative. If you multiply the function with a constant k, then the whole derivative gets multiplied by k. And so we get our rule that the derivative, when, let us say, of a function, let us say if if y equals to f of x, in that case, the derivative is f prime x, right?
Yeah.
But if I multiply this by k, in that case, the derivative also gets multiplied by k. That is what I'm trying to say, right? So,
Yeah.
in a way, it is written like this, that the derivative gets multiplied by k.
Okay.
Also, in derivatives, if we have sum of two things and we're trying to find the derivative of that, then it is same as the individual derivative or the difference. And that really helps us to find derivative of tangents for polynomial. To give an example, if I
Yeah.
have any function f of x as, let us say, 2x cubed minus 3x squared plus 2x minus 5, right? In
Yeah.
that case, what is the derivative of this function? Using the power rule, it will be 6x squared, right?
Yeah.
Minus
Minus
6x
6x.
plus 2, and that is 0. So what we
Yeah.
have done here basically is that we have found derivative of the first term, correct?
Yeah.
Subtracted the derivative from the second term, third term, and fourth term, which was 0. So you can add and subtract the derivatives. This is what we mean by using the sum rule and the derivative rule, correct?
Yeah.
Let us take up an example based on these rules. Uh, Here is an example for you. Can you please read the question?
Yeah.
So it says determine the equation of tangent line at p equals to 1, 3 on the
Yeah.
curve f of x equals to 3 times cube root of x squared, right? So
Yeah.
tell me, how will you find the equation of tangent line? What are your steps?
I think we first find the derivative of that.
So we have the function which is 3 times. I can write this as x to the power of 2 over 3, right?
Yeah,
So the derivative of this function will be 3 times 2 over 3x,
yeah,
and the power will be 2 over 3 minus 1, right? So 2 over 3
yeah,
minus 1 will be minus 1 over 3, correct?
yeah,
So which is 2 over cube root of x.
yeah,
We need to find the tangent at a point P, which is 1, 3. So if I substitute 1 here, then I get the derivative at point x equals to 1. And so that is 2, right?
yeah,
Once we know the derivative and we know the point, we can find equation of the tangent line, correct?
yeah,
So if you notice, the graph of the function is given to you, which is a cusp at 0, and the point 1, 3 is also shown along with the tangent line, correct?
yeah,
And you can easily find the equation of this tangent line using the formula y minus y1 equals to m times x minus
X,
x1, correct?
X1, yeah,
So we use this formula y minus y1 equals to m times x minus x1.
yeah,
Substituting the value of m as 2 at the given point, and the point itself is 1, 3, we get y minus 3 equals to 2 times x minus 1. Now you can simplify this. It comes to y equals to 2x minus 2 plus 3, which is y equals to 2x plus 1, correct?
yeah,
So you get the equation of tangent line. Now, here is a thinking question for you based on what we have done just now. Question number 4. Can you please read question number 4?
yeah. Determine the equation of normal at P.
Correct.
Find x-intercepts of the normal and the tangent. Find the area of the triangle PQR where Q and R are the x-intercepts.
Correct. So this is a great question which is normally seen in test papers. So basically, now we are trying to find the normal at P, right? So that means at this, if I draw a normal, then these it will be kind of like this, right? Right angles to the tangent,
Yeah,
right? So that means the normal slope will be what? Let me write down slope of the normal will be minus half, correct? Negative reciprocal of 2. We know the point and we can find the equation of normal, right?
yeah.
So what should be
Wait,
the
what do
equation?
they mean by normal? Like, what do they mean by
Perpendicular.
equation normal?
Perpendicular.
Oh, okay, okay. So
So,
how do we find like a perpendicular to the line?
so it says
Oh,
this.
yeah,
Okay, so the slope of perpendicular, let me write down. Slope of normal or perpendicular, which is perpendicular, will be what? Will be negative reciprocal, right?
yeah. The rest,
Instead
yeah,
of 2, it will be minus half, correct?
minus half, yeah,
And therefore, the equation of line will be y minus, and we know the point still remains the same, which is 1, 3, right?
yeah,
So the equation will be y minus 3 equals to slope, which is minus half times x minus 1, correct? Cross multiply 2 times y minus 3 equals to minus x plus 1, correct?
yeah,
And now we can open the bracket. So we get 2y minus 6 equals to minus x plus 1. Bring x on this side. X plus 2y minus 6 minus 1 equals to 0. X plus 2y minus 7 equals to 0, correct? So that becomes the equation of normal, correct?
yeah,
Now the question here was that, so we got the first part. Now you have to do the second part, which is find x-intercepts of the normal and the tangent. You get the idea? So
yeah,
tangent equation is given to us. We can find the x-intercept, right? And for the normal also, we'll find the x-intercepts. So now let's find x-intercepts for the tangent first. Tangent equation is y equals to 2x plus 1, correct?
yeah,
And x-intercept means y is 0. So we have to find the x value. So clearly it is minus half.
minus half, yeah,
Now Let us find the x-intercept of normal. And that is, the equation is, we wrote like this, x plus 2y. We can write this as equals to 7. When y is 0, x is equals to 7, right?
Yeah.
So we have the two x-intercepts. And the point given to us is 1, 3, correct?
Yeah.
So if you look at the graph, then you can make, this is a triangle, correct? Whose area
Yeah.
you have to find. So let me redraw.
Oh, yeah. Yeah. Yeah.
Let me redraw this triangle here. It could be drawn like this, right?
Yeah.
Kind of, right? Where the point P is 1, 3. This x-intercept was minus half, and the other one was 7, correct? So what is the area of this triangle? Since it is a normal, we know this is a right angle triangle, correct?
Oh, yeah. Yeah. It's perpendicular.
Perpendicular. So now
Yeah.
you can find, but easier method is definitely, because you know the point is 1, 3, we know the height is 3, right?
Yeah.
Height is 3, and this distance is how much? 7.5, correct? So area of this triangle is half of base, which is 7.5 times height 3. You get the idea.
Yeah.
So that is how we can actually find area of this triangle. This is an excellent question which is asked in test papers. So it's kind of extension of what we have learned, just the derivative, application of finding equation of tangent, application for finding the normal, finding the x-intercepts, thereby the triangle, and area of triangle. Does it make sense?
Yeah.
So is this concept clear to you?
Yeah.
Great. Let's look into another example, which is also very important. Many times we are interested in finding the points where the tangent is horizontal. Can you tell me why? The idea is, if you have a horizontal tangent, that means it is a turning point. You see that part.
Yeah.
So we get the local maximum or local minimum on a curve by finding the points where the tangent is 0. These are also called critical numbers. These are critical points.
Okay.
The right points or numbers, right?
Yeah.
Where the derivative f a equals to 0. Is that okay? Well, critical number also includes the points where the derivative does not exist. Means a cusp or a corner. You get the idea.
Yeah.
Okay. Or it could be a vertical tangent like this. So that
Yeah.
is also a critical point.
Yeah. So wouldn't that point also be called as like a wait? This is a cubic function.
This is
Is
a
it?
cubic.
Yeah. So wouldn't it be also like a Reynolds point or like as you call it or like
Yeah,
as I
point of inflection. So
yeah,
there could
inflection
be,
point. Yeah.
yeah, so they could be like this, right? So this is point of inflection, right?
Yeah. Yeah. Yeah.
Where
That's where the tangent
horizontal
comes
is
from.
0, right? So here the horizontal is 0, correct?
Yeah.
But here the horizontal does not exist. What I mean, the tangent does not exist, derivative does not exist since the tangent is vertical. You get the idea.
Yeah.
So both are very critical points. So the critical point is the one where the derivative is either 0 or it does not exist. You get the idea.
Yeah.
Perfect. Can you please read the question and try to answer this?
Yeah. Find the equation of normal at x is equal to 1 on the curve of f of x.
No, no. No, you're looking
Wait,
at this.
is it,
Find the
yeah.
points of the curve f of x.
Oh, that question. Okay, I thought you
Yes,
meant the one on the bottom. Okay. Yeah. Find the points on the curve f of x is equal to negative x cubed plus 3x squared minus 2, where the tangent is horizontal.
where the tangent is horizontal. So what will you do for this? You'll find the derivative, right? Using the
Yeah.
power rule and the sum
Yeah.
and difference rule, right? So for a polynomial, the function is given to us as minus x cubed plus 3x squared minus 2. We applied the
Yeah.
power rule to find the derivative, which is 3x squared plus 6x, correct? Horizontal tangent means that the derivative should be 0, correct?
Yeah.
Equating 0 for the derivative, we get an equation 0 equals to minus 3x squared plus 6x. Factor and find the values, where x value gives you a 0 for the derivative. X equals to 0 and x equals to 2 are the 2 points, correct? So if you substitute 0 value for x, you'll find the y value of 0. And if you substitute 2, you'll find the y value corresponding to that. And that gives you the 2 points 0, 2 and 2, 2, correct?
Okay.
So if you substitute 0 in this, you get minus 2. But if you substitute 2, you get 2, correct? So at 0, you
Okay.
have a value of minus 2. And at 2, you have a value of 2. Now,
So
these
basic, yeah.
points, as you have seen in the diagram, are also the turning points, correct? Well, actually, we can actually analyze whether these turning points will be maximum, minimum, or neither. You get the idea. We can do that, but I think that's the later half of the calculus part where we analyze the derivative, right? For example, you see here, this derivative is 0 here, right?
Yeah.
However, it is not local maximum or minimum, and it is not a turning point. Do you see that? So therefore, you might have derivative as 0, but it may not be a local maximum or local minimum. That is to say, it may not be a turning point. You get this idea?
Yeah.
Aryan, it's very important. Derivative is 0 for these 2 points, but they are turning points. Here, derivative is 0. You can see a horizontal line will be tangent at this point, but it is
Wait.
not a turning point. You get the idea?
Yeah. So I have a question.
Yes.
So I'm still a little confused. How do we get like that the horizontal tangent is 0? So like we find the derivative first of the function, and
Okay.
then
Let's redo it. So we have
yeah.
a function f of x, which is equals to minus x cubed plus 3x squared minus 2, right? Let's find the derivative of this function, which is
Yeah.
minus 3x squared plus 6x, correct? Now, if the tangent is horizontal, means slope is 0, correct?
Yeah.
So therefore, we'll equate this to 0 and find the value for x. This is a quadratic equation. We just factored out x minus 3x here. So you get what? You get x minus 2x, 2, right? X is factored out.
Oh, okay. Okay. Yeah.
And
Yeah.
so we get two zeros, one being at x equals to 0, and the other one at x equals to 2, correct?
Yeah. Yeah.
So we have these 2 points, x equals to 0 and 2. Now let's find the value of y. If I substitute 0, you get y equals to minus 2, right? If I substitute
Yeah.
this as 2, then you get what? You get minus 2 cube plus 3 times 2 square minus 2, and that could be minus 8 plus 4 times 3 is 12 minus 2, and that gives you plus 2 as your answer, right?
Yeah.
So we get these 2 points. The one is 2, 2, and this one is 0 minus 2. Is it clear to you?
Yeah. So basically, what we just do is after we like factor it out, get our values, we just plug it back into the original equation.
Correct. So that is how you have to do it. Correct.
Okay.
So you understood this. Now, can you answer question number 5, which is find equation of normal at x equals to 1? How will you do that?
Yeah.
X equals to 1 is here.
Hmm?
Yeah. How will you
Okay.
find equation of normal at x equals to 1?
Oh, okay. Yeah. You would just plug in the one back in.
Yes.
Yeah.
So derivative is given to you. Just plug in 1 here. So minus 1 square, right? Plus 6 times 1, which is minus 3 plus 6, correct? Which is plus 3, correct? So that becomes the slope. But we want the equation of normal, correct?
Yeah.
So for normal, the slope will be Negative reciprocal, which means minus 1 over 3, right?
Yeah.
And now that becomes the slope. And the point is, let us find what is the value at 1. If I substitute 1 here, we get minus 1 plus 3 minus 2, which is 0, right? So the point is 1, 1 0, right?
Yeah.
And therefore the equation will be, let me write in a different thing, y minus y value of 0 equals to slope minus 1 over 3 times x minus 1, correct? So cross multiply, we get 3y equals to minus x plus 1, or we get x plus
Okay.
3y minus 1 equals to 0. Is it okay? So
Yeah.
that is how you can find the equation of the normal at any other point, which is in this case x equals to 1 for the given curve. Clear?
Yeah. So to find normal, we just plug in that x value and then like back into the equation, and then like the line that like the line that we like the equation we get is this our normal.
Correct. Normal
Okay.
means negative reciprocal slope, perpendicular. Clear?
Okay. Yeah.
Now, based on our learnings, here we have a couple of questions for you. Question number 7. Let's try to do it. Please read the question, then we'll try to solve it.
Yeah. Find the point on the hyperbola xy is equal to 27 where the tangent line is parallel to the line y is equal to negative 3x plus 2.
How will you do it?
Yeah, so basically, I'm pretty sure when it's parallel, the slope is
Same.
the same,
Yeah.
and like the y-intercept is just what's different.
Yes. So slope is same. So slope of the line is 3, right? So you are solving question number 7, correct?
Yeah, question number 7.
Right. And the equation is given to you as xy equals to 27. It's a good idea to write this as y equals to 27
27 over. Yeah,
So the derivative is what? So the derivative is, this is like 27 times x to the power of minus 1, right? So that gives you negative 27 over x squared, correct?
yeah,
So it says find the point on this hyperbola where the tangent line is parallel. That means this derivative is minus 3, correct?
yeah,
You will write minus 3 equals to minus 27 over x squared. So x squared is equals to 27 over 3, correct? Minus minus cancel, which is 9. So x is equals to plus minus square root of 9, which is plus minus 3. Is it okay?
yeah,
And now we know 2 points. So the y value will be, when you plug in 3, positive, you get 9, right? So the point is, if you put 3, then 27 divided by 3 is 9. But if you put minus 3, then you get minus 9. So these are the 2 points where the line is parallel to the given line. Tangent is parallel to the given line. Does make sense to you?
yeah,
Correct. So the solution which we just did is shown here with the help of the diagram. So let's go through this solution once. So tangent is parallel to this line. That means the slope of the tangent is minus 3. So slope of the tangent is dy dx, or the derivative. Let us isolate y from the equation. Y equals to 27 over x, and dy dx will be 27 over x squared with a negative sign. Since we know that this is equal to minus 3, we can now find the value of x as plus and minus 3. For both plus and minus 3, we get the y value as plus and minus 9 respectively, and therefore the 2 points are minus 3, minus 9, and 3, 9. Is that clear?
yeah,
Now let's look into question number 8. Can you please read question number 8? We'll try to solve this.
yeah. 1 second, I'm just plugging in my charger.
Yeah, no problem.
Um, find the equation of the normal to the curve y is equal to negative 8 over x plus 5 at the point 8, 1.
So again, we have to find the normal. So we'll find the tangent equation and then tangent slope and then reciprocal, right? So can you tell me y is equals to minus 8 over x plus 5. So what is the derivative here?
The derivative is just I think it's just minus 8. Yeah, 8
8
over
over x
x
squared, correct?
squared.
And we
Yeah,
know the point is 2, 1. So we'll substitute 2 and 1. So 2 is x value. So derivative at 2 will be 8 over 2 square, which is 4. So we get 2, right? So that is
Yeah.
the derivative m, right? Now we want the perpendicular because we are working with normal, so it will be minus half. And then we'll follow the same process of finding the equation using the line y minus y1 equals to m times x minus x1. Is that clear to you?
Yeah.
So as you can see in these examples, we could follow this method and then solve these type of questions, correct? So I think the power rule is clear to you, and we have done a couple of examples based on that, right? We can move on to the product rule, right? Is this clear to you?
Yeah. Yeah.
So we'll move on to the product rule. Now here is the product. This is the quotient rule which I'm showing you on this. Product rule is right there. Okay. So here is the product rule. So if you have product of the function as written here, f times g, right? F times g is the, if f and g are differentiable, then fg is also differentiable. And the derivative is, you can derive the derivative, which is shown here. However, let me give you the formula right away, right? You can go through this derivation in your book. So if I have the product of these two functions, then the derivative will be equals to derivative of the first times the other plus first times the derivative of the other. You get the idea. So
Yeah.
basically, you add the derivatives. That's so simple as that. So that becomes the rule, which is the product rule. Okay. Now,
Yeah.
which we have mentioned here actually, as you can see here, it's written. Now, also you can make a note of the quotient rule. If I am considering the quotient of the two functions, f over g as shown here, right?
Yeah.
In that case, the rule is that that is the rule.
Okay.
So let me write down big and bold. That is to say, if we have f over g and we want to find this derivative, then basically it is g squared and derivative of f times g minus f times g derivative, right? So that becomes the quotient rule. Clear?
Yeah. So I have a question.
Yeah.
Um, so let's just say we have a quotient rule, right? Couldn't like, so basically instead of just doing the quotient rule for like, let's just say we have like a function where it's like 2x plus 3 over 3x plus 5. Um, like instead of just like doing a quotient rule, couldn't we just like also do the product rule, where we
Yes.
just yeah.
Let's take up an example. So that's a good question actually. So I actually will take up any example and then work it out, right?
Okay.
So let us say that we have a function f of x, which is quotient of two functions, right? So we'll keep it simple. Let's say we have 2x plus 3 divided by 5x minus, let us say minus 1. Okay. So let us say this is our function. Now, you could also write this function as 2x plus 3 times 5x minus 1 to the power of minus 1. You get the idea.
Yeah.
So as you were saying, we could apply either quotient rule or product rule, correct? So if
Yeah.
I use the product, can you find the derivative for this? So if I have to find the derivative of this function, using the quotient rule, it will be square of 5x minus 1.
Yeah.
Derivative of 2x plus 3 is 2 times 5x minus 1 minus, we have 2x plus 3 times derivative of denominator, which is 5. Is that clear to you?
Okay.
But if we do the product rule, then we could also write this as derivative of the first, which is 2, right? Times
Yeah.
5x minus 1 to the power of minus 1. I'll write in the denominator 5x minus 1 plus 2x plus 3 times derivative of this, right? So 2x plus 3 times derivative, that is minus sign. So it will become minus and it will go in the denominator 5x minus 1 whole square. Do you see that?
Yeah.
So you could take a common denominator. So if you take a common denominator, you get 5x minus 1 whole square. And here the 2 gets multiplied by 5x minus 1. And here we have minus of 2x plus 3.
Okay.
Okay, I missed this 5 while writing the derivative, right? So this will be times 5. Inside function, that is the chain rule, which you haven't learned so far. But so what you see is you get the same result. You see that part? Correct?
Yeah.
Exactly same. So when there are quotient, sometimes we do prefer to use product rule. However, quotient rule is better because it saves you one step. You see that clearly, right?
Yeah.
So that is kind of important to understand. And now let me clear this, and we can take some questions from your notes. So let me share with you your notes, which you just send them over. Here we have some examples from you. So uh, we have the first example, which is equal to, we have product of two functions. Okay. So let me write down bigger. Okay.
It's a little like small, and I like yeah. I
There's
already did the first like 3 problems on my own. That's why like it's like written. So can we just start from 4?
which one? Fourth? This one?
Yeah, because I already did 1 through 3 on my
Okay.
own.
So we can
Yeah.
start with fourth, which is g of x equals to x plus 1
Yeah.
times x plus 2 over x minus 1 times x minus 2, right? So
Yeah.
now you have a quotient and the product rule both involved in this, right?
Yeah.
So you could say if I use the quotient rule, it is denominator square, which is x minus 1 times x minus 2. Both are squared, right? So let me square them like this. Is it clear to you?
Yeah.
Now,
Wait, why are we squaring it?
denominator square, right? That's the rule, correct?
Oh, okay. Yeah. Quotient rule.
Quotient rule.
Yeah.
Now, what is the derivative of the first term? The thing is,
1.
we can do that separately. You understand?
Yeah. Yeah.
So we'll write p of x as the numerator, which is equals to x plus 1 times x plus 2, right? So the
Yeah.
derivative of p of x, which is the numerator for us, will be derivative of the first, which is 1 times x plus 2
Yeah.
plus derivative of the second times x plus 1. So this is what you get, right? Which you simplify, you get 2x plus 3. Is that clear to you?
Yeah.
And let me write q as the denominator. So derivative of denominator will be 1 times x minus 2 plus
Yeah.
x minus 1, right? Which is
Wait.
2x
Are
minus.
we doing the wait? Are we doing the addition rule for the oh sorry, the product rule for
I have written this as px over qx, just to
yeah,
simplify.
yeah.
So px derivative is 2x plus 3, right? And
Wait.
the denominator derivative is 2x minus 3. I
Oh,
did
okay,
it
okay,
separately.
okay, okay.
Now I am doing derivative of numerator is 2x plus 3, right? So basically I'm writing derivative of p x times qx basically minus px times q prime x. Do you see that? In short, you get the idea.
Yeah,
So doing it separately helps. So now we can write derivative of px is 2x plus 3 times qx, which is all this, x minus 1 times x minus 2 minus px is x plus 1 times x plus 2 times the derivative, which is 2x minus 3, right?
yeah. Wait. So wait. You mean that that's multiplying by 2x plus 2, right?
Yeah,
Because
yeah, yeah.
yeah, it looks like you're. I thought you raised it at first, so I was just
No,
like,
no,
like
because
you're
this is
just
white,
yeah,
right? So I have
yeah,
to,
yeah,
it's multiplied, right? And the denominator is x minus 1 whole square times x minus 2 whole square, right? You can actually simplify this, but most of the time when we give this question, we say do not simplify. You get the idea?
Yeah.
Because we want to see how you're applying the rules. So what you learn here is that if there are too many terms there, you can write them separately, just as we wrote g of x as p of x over q of x, and separately shown their derivatives so that they can be applied in the formula and calculate very easily as we have done in this example, correct?
Yeah. And then we can just simplify this down after.
If
Like,
required.
yeah.
It is not necessary if required, right? They normally mention do not simplify also. Okay, let's do example 5, which is find the equation of line tangent to the curve at the given point, right? This is similar to what we practiced, but this is with rules, right? Product rule or quotient rule. Y is given to us as, is it x cube or x squared? I think cube, right? Over 2x. Okay, I'm assuming this is x cube. Is it okay?
Yeah, it's x cubed. It's x cubed.
And x at x equals to
Yeah.
1. So
Yeah.
let's find the derivative. So y prime is, we can apply the quotient rule or product rule as you wish. So if I apply the quotient rule, I get 4x squared in the denominator, 3x squared times 2x minus x cubed plus 1 times 2. That becomes the derivative. Let me simplify. So we have 3 times 2, 6x cubed minus 2x cubed minus 2 over 4x squared. So that gives you 6 minus 2 is 4,
Yeah.
4x cubed minus 2 over 4x squared, correct? We are given the point where x value is 1. Well, if
Yeah.
x is 1, then the derivative for x equals to 1 is equals to 4 minus 2 over 4, correct?
Yeah.
Which is 2 over 4 or half. So we know the slope is half. Now you also need to find the point, right? So what is the value of y for x equals to 1? Substitute, right? So you get 1 plus 1 over 2, which is 1. So the point P, we can say, is the x value and y value being 1, 1.
1. Yeah.
Now we know the equation of tangent line with the slope m at this point is half, and the point P is 1, 1, correct? And therefore, y
Yeah.
minus y1 equals to half of x minus 1 multiply. So 2y minus 2 equals to x minus 1, or 0 equals to x minus 2y plus 1, correct? So that becomes the equation. Is that clear to you?
Yeah.
So that is how you could actually solve such a question. Is this concept absolutely clear?
Yeah.
Good. Okay, now we can skip the others. Let me take the last question, which is question number 9. Can you please
Yeah.
read question number 9?
Yeah. Find the points on the curve. Y is equal to 2x cubed minus 3x squared times 12x plus 20, where tangent is parallel to the x-axis.
Parallel to x-axis means horizontal means derivative is 0, right?
Yeah.
Okay. We are given the equation y equals to 2x cubed minus 3x squared minus 12x plus 20. So what is the derivative? 6x squared
X
minus
squared
6x minus
minus 6x minus 12. Yeah.
And if I want parallel, that means the derivative should be 0. Let me equate this to 0 because this is parallel to x-axis. So this is a quadratic equation. We can take 6 common and we get x squared minus x minus 2 equals to 0, and minus 2 will give me a factor of x minus 2 times x plus 1, right? equals to 0. So x equals to 2 and x equals to minus 1 are the two x values. So the points will be plug in 2, right? So f of 2 is what? Calculate with 2, right? So 2 times 2
Yeah.
cubed minus 3, 2 squared minus 12 times 2 plus 20. Calculate this value and also f of minus 1. So 2 times minus 1 cube minus 3 times minus 1 square minus 12 times minus 1 plus 20. Is it okay? So calculate these values. You get the points of interest where the slope of the line is tangent, right? So those are the turning points for the given equation. You get the idea.
Yeah.
So this parabola, leading coefficient is positive. So this parabola will be kind of like this, right? And we have one point at minus 1 where the tangent is horizontal like this. The other one is here, right?
Yeah.
So you once you calculate, you can plug in the points, and that is how you can do such questions. Clear?
Yeah.
So once you know the rules, finding derivative is not so difficult. Second, we have also understood the concept that horizontal tangent means derivative is zero. This is
Yeah.
also called a critical point since it could be a local maximum or local minimum. Correct? In
Yeah.
later classes, we will analyze these points, and these points will help us sketch the graph of the function also. Correct?
Yeah.
So we'll look into these things in the next class. Now, since we do have some more time, I'd like you to do question number 7.
Okay. Number 7.
Yes.
Yeah. Find the equation of the line perpendicular to the tangent. Okay. Yeah. So let me first find it. Yeah. I think I got it. The slope is negative 1/9,
Okay.
and then the equation is it says negative 1/9 x plus 2/9 plus 3, which I'll simplify real quick. All right. Yeah, it says it's about let's
So
see,
perpendicular to
29
the
over 9.
tangent. Perpendicular means negative reciprocal, right?
Yeah, yeah, yeah.
And now you know the point, so you can find the equation, which is y minus 3 equals to negative 1 over 9. I should have written 9 times x minus 2. Okay. You get 9y minus 27 equals to minus x plus 2. X plus 9y, and that is minus 29 equals to 0. So that becomes your equation, correct?
Yeah.
So that is how you could easily do these questions. Do you have the confidence now to do them all?
Yeah. Yeah, yeah, yeah. I can do them.
You can definitely do them, right? So I left question number 8 for you to try. It'll be good if you try it on your own. Find the equation of tangent line to the curve. We can apply the product rule when x is equals to 1. Good job.
Yeah.
Correct. So do that on your own, and then we'll continue from here in the next class.
Just quickly before we end, do you think we can just do a couple of the problems on the other worksheet that I sent you?
Okay.
Yeah, I just wanted to like do.
Okay. So the other worksheet, I think this one we did, right? Oh, both are same. Wait. I I I opened both same worksheets. You mean this one, right?
Yeah, that one, that one.
You can see the screen, right? The
Yeah,
new
yeah,
worksheet you can see, right?
yeah, I can see it.
Very good, very good. Okay. So can you please read the question from the top? What are they saying?
Yeah.
Find and classify the critical points, right? Find
critical
the
points. Yeah.
intervals f of x is increasing. Find the intervals f of x is decreasing. Sketch the graph of f of x, right? So I can
Yeah.
give you the concept here. So as I said, when they say critical points, it means what?
Yeah.
Critical points are points where the derivative is equal to 0 or the derivative does not exist. Is it clear?
Oh, my teacher just said that the critical points, like he wanted us to consider them as like relative extremists.
Yeah.
Yeah, yeah, yeah. Yeah. Oh, yeah. It's the same thing. Okay. Okay.
So these will result into extremes. Is that okay?
Yeah.
So
Yeah.
those
Yeah.
are the critical points. So let's take first example, which is f of x equals to 3x squared
Minus 3x plus 2.
minus 3x plus 2. So the derivative will be 6x minus 3,
Minus 3. Yeah.
6x minus 3. When is it 0? So we'll equate this to 0. So x is equals to half, correct? So at x equals to half, we have a critical point. And that also means that it is a turning point, right? It's a parabola, clearly. So if it is a parabola, we can sketch this parabola also. It's kind of like this, correct? So what we found just now is that at turning point happens at x equals to half. Clear?
Yeah.
So that is the turning point. Now, the question was find the interval where the function is increasing. So you can actually analyze the derivative, right? So we have this derivative, which is equal to 6x minus 3, right? So let us analyze it. This derivative is 0 at which point? 0 at half, right? So let us take a point on the left side and a point on the right side of this. So 0, x equals to 0 could be on the left side and x equals to 1 could be on the right side, correct?
Yeah.
Let's find the derivative at both these points. On the left side, if I plug in 0, because the equation is 6x minus 3, right?
Yeah.
So if I plug in 0, I get what? Minus 3, correct?
Minus 3. Yeah.
If I plug in 1, I get plus 3, correct? So what I'm saying
Yeah.
is derivative is negative on the left side. Negative derivative means decreasing. You get the idea?
Yeah.
And positive derivative means increasing. Do you see that? So therefore, we can say that this particular graph is decreasing from minus infinity to the turning point, which is at half.
Yeah.
And it is increasing from half to positive infinity,
Yeah.
as you can also see in the graph. So both the things are now related, and based on this, we can sketch the graph just as I have shown, correct? Because we know
Yeah.
this particular point, which is the turning point. Just plug in half here, get the y value.
Yeah.
So you can easily sketch the graph. Is that okay?
Yeah.
So that is how we could actually analyze the critical points and sketch the graph.
Okay.
Okay, great. So we're going to end this class here. Can you summarize today's learning?
Yeah. In today's class, we went over the product rule and the quotient rule and how to apply it. And then we also just did some practice problems where we like solved for the tangent that's line for the derivative and like the perpendicular line, also called as normal. And then now we just dealt with like the increasing, decreasing, and critical points for
Correct.
some graphs.
Good. Well done. So you learned a lot in one class. That's excellent. Good job. See you in the next class.
Thank
Have
you.
a good night. Bye.
Thank you. Good night.